Okay, good afternoon, everybody. It's time for our review for the second exam. As you noticed already, we're going to be recording this session. So if you want to look at the video later today or tomorrow, you will have access to the video. So in terms of the exam, is scheduled for Wednesday, October 28th, which is this Wednesday for this week, 2 days from today. And the exam is going to be, in terms of the format, similar to the first exam. You are going to access the exam using Canvas, and also you will have from 3:30 to 5 p.m. to work on the exam. And then you will have some extra time, like we did last time, extra 15 minutes to use that time to upload the materials that you will be, if you have any documents that you need to scan and upload in terms of the, in terms of the answer the questions, to answer the questions. So most likely you, as you saw on that first exam, you have a group of questions that are 10 questions that are true or false questions or multiple choice questions, and then you have problems. So let's talk about the format and the exam and the topics that are going to be covered. So the exam, as I mentioned already, is scheduled for Wednesday, October 28th from 3:30 to 5 p.m. And it's going to have two sections, as same format as the first exam. So the first section, you have 10 questions that could be multiple choice or true or false questions. So that's section 1, in which each question is 2 points. So the total for section 1 is 20 points. And then section number 2 is section 2 is 3 problems. In this exam, you will have 3 problems that you will answer using a sheet of paper. So you will solve the problems, and you are going to scan those papers at the end of the exam, and you're going to upload those into Canvas. So these questions will have a link for you to upload the file. So as I mentioned in the first exam, you have 2 options. You can upload a single file for each question, or you can group all the answers, all the papers in one document, and then upload that single document to one of the questions. So I will accept both of the options. So again, you can upload the answer for each question individually to each question, or you can group all the papers into a single file and upload that file to Canvas. So in terms of the lectures that were covered for the second part of the semester, we started with lecture 5 that discussed supply chain management. And we covered topics such as what is supply chain management, a supply chain strategy framework, components of the supply chain management, and the major obstacles and common problems. So for this particular lecture, you should expect to see some of the questions in section 1. So there's going to be questions in terms of the concepts that were discussed on that lecture. So for example, what is supply chain management? What are some of the components? So my advice for this lecture is that you go through, you familiarize yourself with the concepts and the definitions and some of the obstacles that we discussed that are common for supply chain management. Then in terms of lecture 6, here's where we start looking at the design of the interior of the facility in terms of the personnel requirements. So lecture 6, we discussed space requirements and layout, things such as structural system performance, enclosure systems, atmospheric systems, electrical and lighting systems, and then life safety systems. So if you remember the assignment that was linked to this section, you have problems in terms of designing the enclosure, the atmospheric system. So we did some computations both for cooling systems and also for heating systems. In addition to that, we look at how to compute and design the lighting system for a specific area of the facility. And in that particular problem, you have multiple guidelines that you have to follow. So those are also things that you need to know how to work with. And so basically, you should expect at least one question from this lecture in terms of the problems for section 2 of the exam. Then lecture 7, we talk about personal requirements. So we talk about the employee and what are the things that we need to take into account when designing a facility. We discuss the requirements in terms of the restrooms. We also discuss the requirements in terms of office facility planning, the barrier-free compliance. In this lecture, we also learn how to design for a parking for a facility. So how to plan for the number of parking for standard cars, for large cars, and also for disability. So that could be also one of the problems that for this exam. I can give you a specific situation and ask you to, using the guidelines, how many parking spaces can you design based on those requirements. So we had a lab on that. So I would advise you to look at that, to that particular lab, and also to look at the example that we discussed in the lecture. In terms of schedule design, that's lecture 8. We discuss 3 major topics: marketing information, process requirement, and the machine assignment problem. So also in this lecture, we discuss how to compute the number of machines for a particular department based on some requirements. And later today, we're going to see one of those examples that is coming from the assignments. But that also could be a problem that I can ask you about a specific, give you some numbers and tell you based on those requirements, compute the number of machines that will be needed for that particular department. So that's also part of one of the assignments that we have for this part of the semester in terms of the material. And then the last lecture that we discussed during this second part of the semester was the lecture 9 on material handling and material handling equipment. So that lecture was more informative in terms of the different type of groups or different groups of material handling equipment that is available. Talking about the uses and what are the differences when you should use one type of material handling equipment and when you should use another. So we talk about conveyors, we talk about forklifts, we talk about cranes. So the important part about that, I can ask you questions also from the first section in terms of concepts. So I would advise you to review the lecture, understand the differences between the different groups, and also understand when in which cases you should use one type of equipment and in which other cases, or the differences in when would you use one type of equipment and when would you use a different type of equipment. So specifically for conveyors, for forklifts, for cranes, there are specifics in terms of when you should use each type of equipment, and you should know about those. So that's in terms of the material that was covered during this second portion of the semester. Those are the lectures that were covered. Now, in terms of how to prepare for the exam. You should study the lecture slides, the labs, and the assignments or the homework. I already posted most of the solutions. If there's one or two that are missing, I will post them tonight. I think there's one of them that is due the day today or the day of the exam. So if it is due the day of the exam, I will post the solution earlier so you can study for the exam. And I will provide the formulas and tables that you will need for answering the questions. So I know that there are some problems that require different set of tables and so on. So in order to help you in terms of making the best use of your time, if a table or formula is needed, it will be provided. So you will see that as part of the description of the exam at the beginning of the exam. So you know that you have access to those. So those will be available in the exam. The exam is closed book and notes. You will access the exam using Canvas. So there will be a link to access the exam in the Canvas modules, just like we did last time. You should clearly show your work and formulas used in your solution. So in case you don't get the right answer, I can still award you with full or partial credit. Sometimes there's just a computation error that most of the process is right, and you will get the full credit, even if the computational number is not correct. So multiple choice true or false questions will be answered using the computer. So like you did last time, you would just click on the right answer for the first section. And I'm sorry, this should be 3. So for the 3 questions or problems, you will upload a file. So basically the idea is that you work the solution in a piece of paper. You take a picture or scan the document and you upload your solution, the file, to Canvas. You will have 15 minutes to upload the files, just like we did last time. That worked very well. So my advice is for you to stop working in the exam at 5 o'clock and then to use the time after 5 p.m. to from 5 p.m. to 5:15 to upload the files. The exam will close at 5:15. So again, the rules are very similar to those that you follow in the first exam. I think there were no issues on that first exam, so I think everything worked very well. So we are gonna follow the same strategy for this exam. So I have some problems that I want to discuss as part of the review. So that's what I'm going to do next. But at this point, I would like to ask if there's any questions.
No, I'm good. Thank you.
Awesome. Sounds good. So let's just go over some representative examples in terms of the questions that you problems that you might face in the exam. So the first one is on computing the heat loss. So let me just use switch. Okay. So so the question is coming from the homework. What will be the heat loss of a facility having the following characteristics if the inside design temperature is 72 degrees Fahrenheit and the outside design temperature is 12 degrees Fahrenheit. So the heat loss will be computed using these coefficients that are listed here on the right. We have QH is the total heat loss, and that's the number that we want to compute. And that involves all these 6 coefficients, which is the heat loss through the floor, the heat loss through the roof, the heat loss through the glass windows, the heat loss through the doors, heat loss through the walls, and the heat loss through due to infiltration. So those are the 6 coefficients. that we need to compute, and then we're gonna add them all to compute the heat loss or the total heat loss for the facility. So for this particular case, we need these coefficients. So the formula in order to compute the heat loss for each one of those pieces of the facility, we have Q equals AU times Ti minus T0, which is the difference in temperature. So the A value is the area of the facility component. So that will depend on what area or what's the specific in terms of which component you're looking at. U is the coefficient of transmission of the facility, so that will be given. And that typically is a parameter that's provided depending on the location of the facility. So I'll provide that for you. And Ti is the temperature inside the facility. T0 is the temperature outside the facility. So what we have in this problem is a facility that has dimensions of 400 feet times 300 feet. It has walls that are 20 feet tall, has no windows, and has 6 glass door measuring 3 feet by 8 feet. So 6 glass doors measuring these dimensions. So once you understand how this works, then it's very straightforward. So in this, for the heat loss, we are gonna use the same formula, Q equals A times U times the difference in temperature. The only thing that we need to be careful is on computing the area associated with the component. So for example, we start with the QF, which is the heat loss for the floor. So the floor will have dimensions 400 feet times 300 feet. That's why we get 120,000 feet square. And we are going to multiply that by the coefficient for the floor, UF, which is given right here, 0.81, and then times the difference in temperature. For the roof, we have the same dimensions. So the roof and the floor has the same dimensions. So we have 120,000 feet square multiplied by the coefficient or the U coefficient for the floor, which is 0.20, and then times the difference in temperature. Then when we get to the doors, it's stated in the problem that we have 6 glass doors, and these are the dimensions. So we're gonna have 6 times 3 times 8, which is 24. So that's the area of the doors. 6 doors times the area of the doors, 20 feet square, times the coefficient for the doors, 1.13, times the difference in temperature. For the windows, for the walls, QW is for the walls, heat loss through the walls. So the dimensions of the walls, you're gonna have 2 walls that are 400 times 20, and 2 walls that are 300 times 20. But for the area of the walls, we also need to subtract the area of the doors. So that's why you have two walls that are 8,000 feet plus 2 walls that are 6,000 feet. 6,000 is 20 times 300. 8,000 is 20 times 400. And we need to subtract the area of the doors. So we have 6 doors, 3 times 8 is 24 feet square. So that's why we are subtracting that area. So the total area for the walls is going to be the area of each wall, the summation of the areas of each wall, minus the dimensions times the number of doors for the doors. So all that times the coefficient for the walls, which is 0.39, times the difference in temperature. The next one is QI. This is the heat loss due to infiltration. So for infiltration, we have the area of the ceiling, which is 400 times 300, plus the area of the 4 walls, including the doors. So we had 2 times 8,000, that's 16,000. 2 times 6,000, that's 1,200. 12,000. So 12,000 plus 16,000 is going to be equal to 28,000. That multiplied by 0.2, which is UI here, times the difference in temperature is going to give you that QI. And then once you have all the components in terms of the Qs for the heat loss, then the last part will be just to add them all, which is what we have here. And the total is equal to 9.7 times 10 to the 6 BTUs an hour. So this value right here is going to tell you the heat loss for the facility, and it's going to help you in terms of determining the type of equipment that you need to have in your facility for keeping a specific temperature inside the facility.
I have a question.
Yes.
How did we get 28,000 again for QI?
So the 28,000. Okay, so the 28,000 is going to take into account the area of the ceiling, right? So the ceiling, which I'm sorry, let me double check. So we get this the area of the walls. I'm sorry, the areas of all the walls. So it's 2 times 8,000 plus 2 times 6,000. That's going to be equal to 28,000. I'm sorry, I think I mentioned the ceiling. That was not correct. Is the area of the walls, including the area of the doors. So it's 2 times 8,000 plus 2 times 6,000. My bad.
So much.
Yeah, thank you for that question. Any other question? Good. So the next problem, this one is to find the number of each machine needed to meet the demand. So in this problem, we are using some of the concepts that we learned in the first part of the semester in order to estimate the required input for each station. And then using that information, we were computing the number of machines that were needed. So the problem states that a part requires 3 processing steps on 2 machines in the sequence ABA. The demand for this part is 10,000 units per week, and the company operates 6 days per week, 8 hours per day. Given the following performance data, find the number of each machine needed to meet the demand. So we have this information. We have operation 1, operation 2, and operation 3. Operation 1 and 3 happens in the same machine, same type of machine, machine A. And operation 2 happens in machine B. We have the standard time, we have the efficiency, the reliability, and the percentage of defects for each one of the operations. Okay, so we need to start identifying the required input values for each one of the parts. And we have all IK values rounded to the nearest integer. So we let A1 denote the first step in the production process, and A2 denote the last step. So for the first step, we know that we can get that input by dividing the required output by the multiplication of the defective rates, 1 minus the defective rates for each one of the operations. And that give us 11,423 units. For IV, again, we only, so this is a 3-step process. So you have A is the first machine, B second machine, and then A again is the third machine. For IV, for the second machine, we will look at the defective rate of the third machine and the second machine. And this is going to be 10,000 divided by the 1 minus 0.05 and 1 minus 0.03. So this is going to be equal to 11,080 units. And then for I, the input of A2, we have 10,000 divided by 0.95. So total number of units that we will need as an input for this third process is going to be 10,526 units. So, so that's the information we got by taking into consideration the defective rates for each one of the machines. Now we want to look at what will be the number of machines needed to achieve these our goals. And we want to have a standard time in order to measure this performance. So in this case, we want to have it in terms of minutes. So we are starting with the business day of 8 hours, and we are looking at 60 minutes an hour for 6 days a week. That will give us a total of 2,880 minutes a week. And we know that our input IK is going to be equal to the QK in our formula for computing the number of machines. So knowing that, we can specify the number of machines of type A by right here. We are doing the computation for the operation 1 and operation 3 together because both of them require a machine A type. So that's why we have two pieces in this equation. We have the first piece for AI, A1, and we have the second piece for A2. So for A1, we are going to use the 11,423 units. So that's the number that we have here in terms of QA1. And for QA2, we are going to use the 10,526 units, which is the third operation. So that's what we have here, 10,526 units. And then using the operation, the information in terms of the efficiency, we can, and the reliability of the process and the time, which we have computed here in terms of minutes per week, we can substitute those values into the formula and get 31.57 machines, which is a fractional number. So we want to always look at the next integer value, right? Because if we need 31.5, 31.6, that means that we need another machine in order to complete the units. So in this case, we always round up in order to estimate the number of machines. So if we get 31.57, if we get 31.10, 31.05, you always round up because that extra fractional value, what it's telling you is that you need an additional machine in order to address all the units that you have. So 32 machines for type A. For B is easier because we only have one operation that requires machine B. So we have only one expression, which is here. So QB is going to be equal to 11,080 units. And then we have the age, efficiency, and the reliability values, same thing. So we multiply this times 3 minutes, and we substitute the rest of the coefficients, and that gives us 12.79 machines. Again, we round up, so a total of 13 machines. So in terms of the number of machines that will be needed, we watched the original question, find the number of each machine. So for A, we will need 32 machines. For B, we will need 13 machines. So again, this is also questions for one of your homeworks. And then the last question is related to the lab for a parking lot design. So a parking lot is to be 400 feet wide and 370 feet deep. How many standard size cars fit in this lot? And I'm going to specify you what module I want you to use. So in this case, I specify I want you to use W2 module, and I also want so you, if that's the only information that I give you, then you are free to design it based on what type of cars. But for the exam, I'm going to tell you specifically, if you have a problem like this, I'm going to tell you this is the dimension of the parking. These are the number of standard of the dimension for the standard cars. This is the angle and the module width. So for W2, we have the module width is going to be 66 feet. We are going to design for standard cars, which have these dimensions, 8 feet and 6 inches. And we want to have 90-degree angles in our parking. So based on that, I can start by determining how many modules the lot of 400, the lot of parking lot can hold. So if you look at the dimensions that I'm showing up here, if you decide to use this as the width to accommodate the number of modules, then that's what I did. I used 370 feet as the width. So I'm dividing that by the dimension or the width of the module. And that tells me that I have space for 5.6 modules. So I'm going to use, I can fit 5 of those W2 modules, but I also have space to fit half or an additional half of the module. So I'm going to round to input 5.5 modules into this area. Each module has 2 rows in it. The only one that has only 1 row will be that module with half of the space. So if you look at my design here, you have 1 module here, number 1, with 2 lanes or 2 rows of parkings. Second module also have two parkings, 2 rows with parkings. Third module, 4 module, 5 modules have 2 rows with parking. And then the last one, since is the one associated with that half of the space, we only have space to accommodate 1 row. Okay, so 5 modules with 2 rows. And then the last module, which is half a module, has only space for 1 row of parking spaces. Okay, so that's my design. So now, based on this, I want to determine the number of cars per lane. Okay, so now I'm using this dimension. Okay, the depth of the parking spaces. So 400 feet. I want to know how many 8.5 feet spaces I can place in each one of these rows. So if you do that mathematical computation, that will be 47 cars per lane. So what that's saying is for each row, I will have 47 parking spaces. So I have 11 rows, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the additional one, the 11 rows with 47 cars per lane. However, I'm not done because, for a parking, you will need some circulation spaces or some circulation lanes or space in which the cars can go in and out the modules. So using the row adjusting for 2 circulation lanes, we are going to use 15 feet. Explaining the lecture, I use 15 feet for the circulation lane. So I need 2 circulation lanes, 1 on this side and 1 on this other side. So I have the 400 feet, which is the length of this side of the parking lot. And I'm going to subtract the 15 feet times 2, which are the space that I need for the circulation lanes. So that will give me a total of, so if I do that computation and I divide by the width of the parking spaces, that will tell me that I can only fit 43. Instead of 47 cars per lane, I can only fit 43 for those lanes that are going to be affected, those modules that are going to be affected by the circulation lanes. So those lanes that are going to be affected by the circulation lanes are those that are in the middle. So the ones that are on the side, they are not necessarily affected by the circulation lanes. The ones that are going to be affected are the ones that are here in the middle. So for example, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Those roads are going to be affected by the circulation lanes. So those are the ones that are marked with green here. So this one, this one, this one, this one, and this one, and same thing on this side. We need to cut these rows in order to make space for the circulation lanes. So if you take that into account, what that means is for row 11, you can fit 47 spaces. For row 1, you can fit 47 spaces. But for the rest, from 2 to 10, you can only fit 43 spaces. So based on that, is what I'm going to use to compute the total number of parking spaces. So for rows 2, 3, 4, 5, 6, 7, 8, 9, and 10 will yield the same number of parking spaces. And then we'll have the ones on the corners will have additional parking spaces because those are not affected by the circulation lanes. So we have 9 lanes with 43 spaces. That's equal to 387 spaces, and 2 lanes with 47 times 2. That's equal to 94. So in total, I will have space for 481 standard cars in this space. So this design is not accounting for the disability spaces. This, in order to make it simple and for you to grasp the idea, this is just looking at standard cars. In the example that we discussed in the lecture, we're also taking into account those spaces for vans with disability and for wheelchairs. So this could be another question that you might see in the exam in terms of the problems. Okay, and that's the last problem that I have here for discussion. So is there any questions?
No, thank you.
Okay, awesome. So remember that what I'm going to do now, I'm going to upload the recording in case you want to watch it later again. I'm going to post the slides with the notes so you have access to them as well. And if you have any other question, if you're afraid to ask me now, you can send me an email and we can discuss. I can set you an appointment to meet tomorrow if needed. So just let me know and I will find a way to help you.
Okay, sounds good. Yep.
Thanks.
That's good. Thank you all. And let me know if you need if you have questions or if you need any other help. Bye-bye.
Bye.